Look around you. Look around you. Just look around you. There. Now take a closer look. Have you worked out what we're looking for? Correct. The answer is calcium. This program, Calcium, follows last week's module and will complete part 1 of your textbook, which accompanies this series. Please ensure that you have your copybook at hand, as you'll be asked to take down notes from the screen at various points throughout the program. Calcium. You may know it as Ginny or Ninny or Peter's pig. But whatever you call it, calcium, valency 1, atomic weight 44, is one of the most important elements known to mankind. As we have seen, calcium occurs naturally within the tooth. Thus, man's very existence is inextricably linked to the white element. Without calcium, man would be unable to process foods and would starve. In this program, we will attempt to show the many uses of calcium as well as a number of experiments. Experiment 1. An experiment was carried out to ascertain whether calcium is soluble in water. First, a quantity of calcium was obtained. Using a mortar and pestle, the calcium is then ground into a fine dust. The chalky dust is poured into a beaker. Next, the beaker is placed under a running tap. You can use distilled water, but be aware of the cost. The calcium water mixture is agitated using a glass rod or pencil. It is then allowed to settle for a while. So, is calcium soluble? Look closely before making your decision. Have you observed the chalky deposit at the base of the beaker? If you have, then you'll have reached the conclusion that no, calcium is insoluble. There is a reason for this. Can you work out what it is? Correct. If calcium were soluble, then our teeth would be open to corrosion through daily contact with saliva. Again, man would be unable to process foods and would starve. Here is a model of a calcium molecule. Do you recognize the triple helix? If you do, write it down. The calcium molecule is built on a semi-permanent structure of 4 electrons supporting 3 protons. The protons feed electrical information to the core of the molecule, where we find the central atom or queen atom. Were the queen atom to leave the molecule, or nest, the effects would be disastrous, as the entire structure would come tumbling down. This is known as the Helvetica scenario. Luckily, Helvetica is a very, very rare occurrence. The Staffordshire Downs. 200 square miles of rolling countryside. And it's here, amongst the jewel of the northwest, that we can observe calcium in action. Holdwick Park Refinery has been producing industrial-strength calcium for over 20 years. Chances are, if you've ever written with a calcium nib or peered through a calcium lens, they've probably come from Holdwick. Let's step inside. Have your copybooks ready. Every day, 6 tons of discarded teeth and bones are brought to Holdwick. They're collected from the various calcic drop-off points around Great Britain. You may have seen one in your town or village. Because calcium perspires, by the time it reaches Holdwick, there's a lot of water to be removed. The teeth and bones are poured into giant canisters, and any excess runoff is filtered away. The dried calcium is then pumped along these pipes. When it reaches this trough, a kind of glorified Besselheim, it's bombarded with millions upon millions of cesium atoms. This process compresses the calcium into a viscose paste. The calcic paste is then heated in giant ovens to 12,000 BC before being left to cool. From 6 tons of raw material and nearly 900 man-hours later, here are the results. Some 12 ounces of pure industrial calcium. This is then stored in an underground lead chamber to prevent the possibility of Helvetica. Now let's take a look at some of the ways in which calcium is used. Have your pen and paper ready. Calcium can be used to make powerful adhesives. It's also used as a strengthening agent in bridges, windows, and was pivotal in the development of Imsumul Bharati Lan. Calcium also occurs naturally in liquid form. You'll know it as milk. In the Jewish religion, it is forbidden to eat milk and meat at the same meal. Foods that contain dairy products are referred to as milchig. Milchig. Write that in your copybook now. Experiment 2. An experiment was carried out to determine whether calcium is a conductor of electricity. First, a simple electrical circuit is constructed. The negative terminal of a 9-volt battery is connected to one end of a Besselheim plate. The other end of the Besselheim is connected via an electrical lamp to the positive terminal. Now for the calcium. A quantity is gently poured into the Besselheim, making sure that it forms an unbroken line between the negative and positive end of the Besselheim. If calcium conducts electricity, the circuit will become complete and the lamp will light. Sadly, the lamp does not light. From the results of this experiment, we can conclude that calcium does not conduct electricity. Now let's see what happens when we introduce some sodium chloride. You'll recognize it as common salt. Let's take a look at the lamp now. The calcium has reacted with the sodium chloride to produce calcium chloride. Because calcium chloride is a conductor, the little lamp lights. Small quantities of Thomason's oil, segnomin, are also produced. Little wonder that calcium chloride is used to power amplifiers for electric guitars. When calcium is burned, calcium oxide is released as a vapor. Although not toxic, if inhaled, this vapor can cause temporary bodily paralysis. For centuries, magicians have been using calcium to simulate levitation. This principle can be demonstrated in the laboratory. Experiment 3. An experiment was carried out to observe the effects of helium gas upon calcium. A pyramid of powdered calcium is formed upon a work surface. Next, an ordinary ping-pong ball is placed carefully on top of the pyramid. Now we mark the midpoint. Then helium gas is released in the vicinity of the pyramid. As our starting pressure, we are using Cinderford's constant of 2.5 coulomb per second. Observe the reaction and note the results down in your copybook. The pyramid of powdered calcium has disappeared. Or has it? The calcium seems to have moved some 8 inches away from its original location. 8 inches. So, what's keeping the ping-pong ball aloft? Surprisingly, the pyramid of powdered calcium is still there. Only its image has moved. This phenomenon is known as calcic image misplacement, or CIM. Turn off the helium supply, and the image of the pyramid of powdered calcium is reunited with the actual pyramid of powdered calcium. Now let's see what happens when we increase the flow of helium by a factor of 5 QPS. The pyramid's image fades as before. This time, it reappears some 11.5 inches away. 11.5. Write that down. Now, we try a factor of 7. This time, the image of the calcic pyramid appears over 500 miles away. We've talked a lot about calcium, atomic weight 44. But what of its sister element, calcium atomic weight 42, or intelligent calcium? Intelligent calcium is not intelligent in the sense that you or I are intelligent, but intelligent in that it is sentient, i.e., it is aware of itself and its surroundings. In the laboratory, scientists are able to communicate with intelligent calcium using a REMS oscillating converter. The REMS measures tiny chemical impulses from within samples of intelligent calcium. Experiment 4. An experiment was carried out to demonstrate the cognitive properties of intelligent calcium. The REMS is connected via its two thin probes to the sample of intelligent calcium. Once the microphone is in place, we turn on the REMS. Get ready to take down readings from the screen. The scientist issues interrogative statements to the intelligent calcium through the REMS, which measures its response.
What is your atomic weight?
It can take a few moments for the sample to respond. The scientist repeats the question.
What is your atomic weight?
There we are. F O R T Y T W O 42.
Where are you?
I N A T E S T T U B E in a test tube.
How do you feel?
C O L D. Cold. Now watch what happens when we deprive the intelligent calcium of oxygen. The intelligent calcium is completely neutralized. Note that down in your copybook now. Over the course of this module, we've learned a lot about the nature, manufacture, and uses of the white element. But remember, whether you're at home, in school, or just out and about, whatever you do, never give a gypsy calcium. Now hand in your copybooks to your teacher or head of class. In the next program, we will look at champagne.